I'm Charles Wilson, Staff Product Cybersecurity Architect at Torque Robotics. This presentation will cover the Secure Settings Option Selection activity. This diagram shows the overall AVCDL training path. If you're taking this training, it's assumed that you've already completed the AVCDL overview training, and additionally, that you've completed the Requirements Taxonomy, Security Requirements, Secure Design Principles, Apply Secure Design, Secure Settings Overview, Secure Settings Identify Options, and Secure Settings Categorize Options trainings. This training will cover the Secure Settings Option Selection activity. Before getting into option selection, let's briefly review where it fits in the overall Secure Settings process. Here's the Secure Settings process which we previously covered in the Secure Settings Overview. Our focus for this training is going to be on the third activity, that of option selection. Within the option selection activity, the Security SME and the Development SME take the Categorized Tool Security Options document from the Option Categorization activity and the element documentation and select the security options appropriate to the element, creating an element-specific Tool Security Options document and generating a Security Options Qualification Report. Now let's work our way through an example of selecting the tool cybersecurity relevant options appropriate to a specific element. We'll be using the Categorized Tool Security Options document created in the Options Categorization activity as input and applying the AVCDL element-specific tool cybersecurity options template, which is described in the tertiary document that goes along with this training as output. It's important to note here that this is just one mechanism for documenting this information. There are any number of ways this information could be documented. In an ideal world, you'd use a database to store this information. Introducing the cybersecurity relevant options to the element level greatly increases the number of variants which need to be tracked. We'll begin by taking the information from the Categorized Tool Security Options document and populating our instantiation of the template for the example that we're going to use. The tool name is GCC, the version is 10.2, the platform is Linux. And here's the tool URL. Now we'll provide the remainder of the information. We have the element name, the element scope, the vendor name, and in this case, it's developed in-house. We come down a bit to the cybersecurity engineer. As a reminder, this may or may not be the same as the individual who did the work for the categorization activity. We also have the development SME, and as always, we have the date of modification and the revision number. For the options, we'll bring across the option ID and the option. We can refer back to our other document if we need to get into more detail, but this is the only information that we need here. For each option, the development SME and the cybersecurity SME will discuss whether or not it should be included in the build. Where it's determined that an option will be excluded, a justification should be provided. In this case, for GCC04, we have that we're excluding it because it's in the may do category. As discussed previously, we're not going to be including any of the options which are categorized as may do. For GCC06, we're excluding it because the check of zero-length bounds is considered to not be relevant to this element because it uses no zero-length arrays. Now here are some general reasons to exclude an option. The element source is not modifiable, so we just can't take up the switch because it will just cause warnings that can't be addressed. The option is not applicable to the element. We can see this here with GCC06. The option might consume too much time for the build process. This is something very tool-specific and will be addressed in the specific tooling trainings. Finally, the option is experimental and should not be used in production builds. This is a concern of tools which are involved primarily in the code generation process. The final step is going to be the generation of the Security Options Qualifications Report. So why again are we doing this human-readable report? First, it's the document of record. It's the thing that shows why we made certain decisions. In the cybersecurity realm, it doesn't matter what you do right. What matters is that when you decide to not do something that's cybersecurity relevant, that you have an appropriate justification. That justification needs to be documented, and this report is that document of record. It's going to be stored away so that if it's ever needed, we can review when the decision was made, who made it, and why. The second point is that this is material that needs to be tracked with the rest of the element documentation. And so it needs to be filed so that when you look at the element in its totality, you can say, this is the history of this element, and this is why we made certain decisions about it. If we need to change those decisions, we'll have the pertinent information all in one place. With that, we've covered all the particulars of option selection. Now let's look at a summary. As we go through this activity, it's important to involve the elements development SME. Remember that it's not the place of cybersecurity to be making decisions for development. We present them with the information that shows what the cybersecurity options are and what the rationale behind having each is, and then development makes the final call as to which of these options are put in place. We want to select the element-appropriate tool options. So again, we're going to work in conjunction with the development SME. We need to provide justification where it's appropriate. When do we need to justify things? When you're excluding them. This is one of the reasons that we record the names of the development and the cybersecurity SMEs. And finally, we want to create a human-readable report so that we have traceability. The materials that were used to cover this example are in the location shown here. It's important to note that this workbook includes all the sheets that were covered in this training. For additional information and to get a more in-depth set of references, the Secure Settings Options Procedure tertiary document is available in the AVCDL GitHub repository. All AVCDL materials, both in source and distribution forms, are available on our GitHub site as shown here. Because of the size of the repository, it's recommended that you either clone the repository or download a zip archive of it if you're not familiar with using Git. Instructions for downloading a zip archive are linked to on the repository's front page. Videos covering various aspects of the AVCDL are available on our YouTube channel, as shown here. It's important to note that all AVCDL materials, except for the introductory blog posts, are intended for product cybersecurity engineering practitioners. With this training complete, if you've completed the other trainings covering the secure settings process activities, you can proceed to the other training at this level, Secure Design Review. Additionally, if you've completed threat prioritization, you can also proceed to attack surface analysis, threat modeling, penetration testing, and vulnerability identification. Additionally, you can either proceed to code reuse or secure coding. Here are the references to the source material used in the creation of this presentation. They'll also be included in the video description. Additionally, this presentation source material will be provided on the AVCDL GitHub repository.